Hi, I'm Ned, and I've started streaming. This is a recording from my live stream over on twitch.tv/NedMakesGames. I'm live most Mondays, Wednesdays, and Fridays at 10 a.m. US Eastern Time. I'd love to see you there. Okay, hey everybody. I hope you've all had a great day so far, and I guess a good Tuesday as well. I've had a pretty good day. Gotten some good work done this morning, so I think I'm ready to start streaming. So the past couple weeks, I've been asking my patrons to vote on the next tutorial after tessellation, and it seems like recreating or basically like a introduction to writing code shaders has won out. So I'm gonna start kind of preparing some of the materials for that on stream today. Basically, I have just an empty project here. Yeah, the tessellation shader tutorial is still coming out, but yeah, there's nothing really I can do on stream because I've just got to write the script, and that's not really very interesting to watch. So I thought I'd move on to the next one. Okay, so basically when you make a shader, you have the shader file, and then like a logic file. So let's call this, I guess, my lit shader. Okay, and a little trick. Shaders don't show up in Visual Studio right away unless you add just some C# script to your project. So if you don't have any C# scripts, just create one called like empty or something. It doesn't actually do anything, and then it will show up in Visual Studio. So my goals for this project is, well, I want to show how to recreate the lit shader, which is, has PBR lighting and everything. And then I want to show how to create custom lighting in that shader. And then we need to go and add, I keep on doing this, 2021.2 features, because they've added a bunch of things. And when I was making sure my tessellation shaders worked in 2021.2, I found out that they pretty much like rewrote a lot of the things to do with baked lighting. So we might have to change a lot to the custom lighting functions that I created for the shader graph earlier. Okay, but let's go ahead. Okay, so we have the shader file, and I guess we'll just start off simple. I like to clean it up because I don't know, I like my programming style as I have braces on the same line as the function name. So this part is like the title of your shader where it shows up in the material inspector. And here's where you can write properties. So yeah, we'll have a main texture, but I think I'm, I don't know. I think, let's see. How does the lit shader, like the URP lit shader, I think calls this the base texture instead of the main texture. So we might as well duplicate it. We could also call it the color texture. What am I looking for? Yes, okay, they even call it the base map, which I guess makes sense because everything else is a map. Okay. A lot of this stuff is going to be a little complicated, but yeah, because I can make like a simple PBR shader, but the lit shader has a bunch of extra information or settings. So I'm not sure what I'm going to include in this tutorial because some of it is a little specific. Hey, Zach Dixon, thanks for coming by. How are you doing today? I recognize your name from somewhere. Was it? Maybe we've talked on YouTube or Discord. It's saying that this is your first time to chat, so yeah, thank you for coming by. Okay, let's see. So, I think I'll call it the color map. I don't know. That makes more sense to me than base map. Although I guess it does have the transparency. I don't know. Okay, so this will be color and transparency. Okay, it was on Discord. I thought so. Oh, right. You were doing those beautiful, the noisy shadows. Yeah, I really liked how that's looking. Okay. Let's see. Maybe I'm just gonna start off one thing at a time. So let's get just color working and move from there. Okay. Fine. All right, so there's all these different tags that you can include in a shader. It kind of just tells some metadata about it. We can copy. So the render type is the important one. I guess we'll only handle opaque shaders. I think you'd have to write a different shader to change this render type. The other mode would be like transparency, but I'm not sure if you can set that in the material. I'll have to look into that because I know people would want to have transparency blending. Okay, but anyway, so this is opaque. Then you have to put this tag here so that it lets you know, or lets Unity know that this is updated for the universal render pipeline. I don't think I need this one. This is like to tell it that this isn't a decal. I guess we can leave the shader model there. Okay, so this LOD I'm just gonna delete because we'll just use the basic mode. It doesn't work like model LOD. Okay, so the first pass we'll have is the lighting pass. This will have, yeah, basically it calculates the color of the model. And I think I'll just copy this and then we can delete what we don't need. Because the code that's generated by default is not updated for URP. Okay, so yeah, well, for now I'll get rid of the comments. So this name is just for debugging. We'll put in, you can also put tags in a pass. So this tells it that this is the light mode or the forward lit pass. Okay, so here we can have different blend modes. I'm going to just delete these for now and we'll add them back in later. I guess this is how you could do transparency, but then that wouldn't change the render type. So let's see what does, let's see here. All right, so it does let you do a transparent type. So, okay, I guess I'm glad to see that that works from the material inspector. So yeah, we're gonna have to create a custom inspector for our new shader, but that's fine. Let's see. This will be the Unity lit, and then let's make a material for my lit shader, and then we'll just put them in the scene together. want to create a sphere. Oh, also, I think, yeah, I haven't set up this project to use URP yet, so let's do that real quick. We just need to create the URP settings asset. And place it into the graphics. Okay. And while I'm here, I'm going to go ahead and change this to did mix games and set the color space to linear. Just for better color quality. And this takes a long time to do if you do it late in the project, so. Okay, yeah, so this is pink because it's using a built-in render pipeline shader, so we can fix that just by dragging that. Oh. Okay. Yeah, so it's not the lit shader. Okay, so this is the universal lit shader. It still lets you do transparent, so that's good to know. They have a bunch of options there. Okay, and then we'll just duplicate this. Okay, so my lit shader obviously is. Why is it disappeared? Okay, well it's not drawing. Oh right, because we haven't actually given it any vertex or fragment shaders yet. Okay, so yeah, it's just going to be invisible. That's fine. Let's set these a little bit apart. And then maybe drag the camera inward. Okay, so now we should be able to test this a little better. All right. Okay, so back to the shader. Yeah, again, we'll just delete this for now. Okay, so this HLSL program starts the, so technically this rest of the code that we've written is in something called Shader Lab, and it kind of just defines a bunch of metadata about your shader. So when you put this HLSL program tag, that tells the shader compiler that the rest of this is actually in HLSL, which is the shader, basically what you use to program all the logic for the shader. Okay. So this tells it basically that this shader doesn't work with these specific renderers, so it's GLES, all that stuff. And then this one is pretty much like what shader model the shader requires on the GPU. And it basically just says this won't run on really old GPUs. Forget specifically what 3.5 added, but for instance, I think you have to do 6.0 if you're using tessellation, which I was last stream. Okay, and then here we define a ton of different keywords. These keywords are all marked local, which means that they exist only like per material. And I think these are all defined by the material inspector. So I think I'll get rid of these for now because we don't actually have a material inspector. So, or they're not defined, they're set by the material inspector. But yeah, we will want these later because you can use it to really, I guess, optimize things. Hi, i3. Oh, you thought I was going to remake the entire URP? That would be a really big undertaking. But thanks for coming by. How are you doing today? Okay, so these are all lighting keywords, and I'll leave these in because when we tackle lighting, you need these in order to be able to receive shadows and things like that. Okay, and then this is, again, more lighting stuff. This is for light maps. And This is subtractive lighting, I think. Okay, and also instancing. I don't think I'm going to support dots instancing in this tutorial because it keeps changing. So yeah, I won't. And I personally haven't really used it much. Okay, and then these final pragmas are where you actually tell the compiler what functions to call for each stage. So shaders have a bunch of different stages. I think we'll only be using the vertex and fragment stage, which you can kind of think of. This one runs once per vertex on the mesh, and then this one runs once per pixel on the screen. It's kind of a way to think of it that's not technically right, but and we can define these vertexes or these functions later. Okay, and then finally we'll include our logic file, which I haven't even created yet, but we will soon. So I'll just call this my lit passes. Okay, so let's go ahead and create that. You can't actually create an HLSL file directly, so I just create a class and then just change the extension to HLSL. Okay, it's gonna have this junk stuff, but we don't need any of it. Okay, so the first thing you want to do in here is due to kind of a quirk in the way the compiler works. You can get bugs where a file is included twice and then it tries to compile it twice and it'll tell you like this function is being redefined. So in order to prevent that, you can kind of, well, not kind of, you just create this keyword here. And then you tell it, don't compile any of this if this keyword's already defined. And then just immediately afterwards you define it. So it'll only reach the code inside once. Okay, so first, let's go ahead and write some structures. One important thing about shaders is you pass information between the different stages using these structures. Sorry, my I have like Invisalign, which is kind of like braces or something, and for some reason it's really messing with my voice today, so I apologize. But okay, so these attributes are what I call the structure that you receive from the mesh. So it contains all the data that's actually like on the mesh object. So it has stuff like vertex position and vertex normal. So yeah, for this means position and object space. I mean, the name doesn't really matter, but I like to put these space tags to keep things straight. And also that's kind of what Unity does. So it keeps all the code looking uniform. But then to actually get the GPU to put the vertex position into this variable, you have to add something called a semantic. There's a bunch of different semantics. They're usually kind of self-explanatory, but this one is vertex position, and then we can also get the normal vector this way. And then I'll also want the tangent vector at some point. The tangent vector is actually a float 4, which we can explain later, but you need this for normal mapping, which I will support, so I might as well just add it already. Okay. Oh yeah, and then of course the UVs. And UVs are in a semantic called text chord, and there's a bunch of them. So like, for example, the color UVs or the texture UVs are in text chord 1, and then there's light map UVs that are in text chord 2. Oh wait, I guess, yeah, so text chord 0 is the first set. But yeah, anyway, that's 0 indexing, always a little confusing. Okay, so then we can call the vertex function receives these attributes. Input. And then also, okay, so now the vertex function needs to return something which will be the input into the fragment function. And I like to call this structure the interpolators because you can see, let's see, like on this mesh, I have the wireframe enabled. So the vertex stage only runs once per vertex on the mesh, but the fragment stage needs to run on every pixel inside that triangle. So how do you figure out the values in between the vertices? Well, basically the GPU interpolates between them. So I don't know, like if this was 1 and 0, then you get a smooth gradient across it. So yeah, that's what, and so everything that you put in these interpolator structure is going to be applied that way. So you want to be careful not to add too much here, but we'll add the position and world space because oh wait, I'm getting ahead of myself. We will need that, but first, okay. The most important thing is you need to send something called the clip space position, which is basically it's the position and like on screen space, and that has this semantic. So you always have to include this, otherwise the shader doesn't really know where to draw a pixel. Besides that, you can add basically whatever you want. I'm gonna have a UV. Also, these semantics don't exist in the interpolator stage, so you have to basically stuff everything into a text chord. But I think there's 12 of them, so I've never not had enough. Okay, so we'll have world space, and then normal and tangent. Why do they call it clip space? It's a good question. I think it's, well, actually, it's because there's like a clipping rectangle, which is the screen size. And basically, if the position is outside of that clipping, well, technically it's a cube, I guess. So the clipping cube, then it just won't be drawn. So I think that's why they call it clip space. Yeah, I think screen space would be a little bit more intuitive, but that's technically different because screen space is usually given in pixels. Yeah, it's a whole thing. It's actually be a good topic for another tutorial. No problem, Zach. Okay, so the vertex stage, like we said, will output the interpolator's structure. So we want to basically define one here. Now, a lot of times in shaders, you'll see something like this, which basically just means we initialize the output structure to have zeros in every variable. But I'm going to just do this because I don't want to forget to fill one of these fields. And so then this will give out an error if I do forget to do that. Okay, so then we'll return it. And then finally we can do the fragment function, which returns a color. And it takes in the interpolators. Okay, and then you have to add a semantic here so that the shader knows what this return value is. I think it's SV target. Okay. Let's see. I'm just going to return white, which is 1. And we'll see if... Okay, well, actually, it's going to throw an error because I don't set the text chord. Okay, so let's just ignore all this for now and just figure out the clip space position so that we can just draw like a white circle on the screen. Okay, so one thing you can do in Unity, our URP, there's this helper function that you can call that will convert object space position to clip space. But to do that, we need to include it. So include. Oh, I forget. It's a long line. So let me just look and see. Okay, well, this will work, I guess. But we actually want the lighting file. Okay, and then we can call that function, which I think is vertex position inputs is the structure it returns, equals get vertex position inputs, and then we return, or we give it the object space position. Okay, let's see. If you're curious how I found out about this, it's in the shader library, and I think it's shader variables functions. Yeah, so vertex position inputs. So this is the actual definition of it, and you can see it's just, it figures out the world space, view space, clip space, and then screen space position. But one cool thing about the shader compiler is you might think, well, I don't really want to call this because I don't need all of these transforms, I just need the clip space. But the shader compiler is actually smart enough to remove code that you don't actually use to calculate the return structure. So really, there's no harm in using this function, even if you don't use everything. But anyway, so I want to, so I can remember, where is it? I just want to tag this, that found in shader variables functions. Okay, I guess this is URP shader library. Okay. So anyway, after that, we can set the clip space position from the structure. Okay, and now our shader should compile correctly. Yeah, we just get a white circle. So yeah, if I turn off the wireframe, you can see it's just flat shading because there's no light. And even when I add, well, I don't have a texture, but let's see. I should get some. I know I have a bunch of nice textures in my foliage. So let's grab, actually I think I have them in my tessellation as well. Okay, so cloud noise. Let's grab some of these for use later. Kind of want, I have like a rainbow texture that I always use to test color. I think it was in my toon shader. I guess I'll get the ramp too in case I use that for custom lighting. Probably not, but okay, so let's set this up. I'm just going to turn off some settings here so it doesn't give me an issue later. Okay. While I was in my foliage, I should have gotten that image with alpha so I could test clips, alpha clipping. Okay, so here, alpha is transparency. All right. So now if I add, even if I add this rainbow texture, it's still outputting white because we don't actually read from it. Okay. So I guess let's output from the texture now. Okay, so the first thing I need to do is we need to pass the UV through. Again, I'll just comment this stuff out because we don't need it yet. Okay, so that's easy enough to do. All right, and then let me move this so I don't keep clicking on the wrong thing. So yeah, I call it the color map. So to add that, yeah, unfortunately you can't just use properties directly in your logic file. You have to define the HLSL variable for it. And to do that in URP, you basically have to use a macro because you don't really know what, like if you're compiling in DirectX or OpenGL or whatever. So yeah, you can do it like that to be platform independent. And a sampler, yeah, it's basically a structure that tells the compiler how to sample this texture. For example, you know, like if you had point sampling or trilinear or whatever. That's kind of what this includes. Okay, and then Unity also has this macro, let's see, that you can do this and it will apply scaling and offset to the UV map. But in order to do that, we also have to define this variable, which is kind of a magic variable that's automatically set based on the offset and scaling inside your material. So basically right here, these values will be automatically set in that variable. Okay, and one other thing I want to do for instancing, I guess we should, well no, let's leave that for later. Okay, so this is fine for now. Okay, so now to actually output that or read from the texture, we want to, I guess first get the color sample. Okay, and then to sample, you have to call this another macro. You pass the color map and the sampler. And then the UV. Okay, and just for future proofing, I'm going to go ahead and grab the UV here because at some point we might, I don't know, change it, and we're going to use it multiple times to sample all different kinds of textures. Okay, and then we can just return the color sample. Okay, and there we go. So now we've got textures. Of course, there's no lighting yet, but we're getting there. Okay, so I guess we could tackle lighting now. So we're going to need the position and the normal at the very least, but I'm going to also go ahead and deal with tangents because I know I will want it later. Okay, so there's another function to transform normal inputs. Just got to, let's just change position to normal, and here you'd pass the normal vector and also the tangent vector. Okay, so let's look at that function. Okay, so you can see it does some stuff here to try to figure out the bitangent correctly. So for in UV space, or when you're working with normal maps, you need something called tangent space, which relies on this tangent vector, which lies like in the same direction as the mesh. So I guess excuse that arrow for a second. So like on the top, or I guess right here, it would point along the surface of the mesh. And the bitangent does as well, because if you notice, basically there's an infinite number of vectors that point along the surface of a mesh at any point. So, but if you have the tangent and the bitangent are perpendicular, so you can define a space using them. And they're supposed to point. So again, if you look at our texture, let's see, how am I going to show this? There's so the UV points usually start 0, 0 down here. So U progresses in this direction and V progresses upwards. So the tangent is supposed to point in the direction that U is progressing, so it would point, I guess, along the, is that longitude? No, that's latitude. Latitude of the sphere. And then the bitangent would point along the longitude, or vertically. So but usually you don't store the bitangent in the mesh because you can derive it this way. And then the sign just makes sure it points in the right direction. But anyway. So now we have that information. We could just pass everything through. Okay. One thing here is that I don't know why they do this, but the tangent world space doesn't include that this the bitangent sign object, which is stored in the fourth component of the tangent vector, and we're going to need that in the fragment function as well. So we kind of just need to add it back in. It's not like it's a huge deal, but it does make the code a little bit more not as clean. Okay, so now we can do some simple lighting by just taking the color and then multiplying it by the light direction dot the normal vector. Okay, so yeah, now we have some really simple lighting. Obviously it doesn't really look very good right now, but okay. Now if we want to get similar lighting to this, we can use Unity's built-in PBR rendering, rendering functions, which luckily they did make relatively easy to call from a custom function, or from a custom shader. Let's see. It's in the shader library .lighting file, and all the way down at the bottom you'll see these universal fragment PBR, and it needs something called an input data and a surface data. Now they don't really tell you where these are defined, so you have to kind of go look it up, and I always forget, so we'll have to go and search for that in just a moment. But yeah, basically you fill out all the data that needs, and then you can just call the function. So we'll take lighting input and surface. Okay. Lighting input and then surface data. Okay. Now let's figure out where these are contained. I think one of them's here. Yeah, so the input data is in the input.HLSL. So found URP shader library input. Okay, and this other one I always have trouble finding. Oh, come on. There we go. I just found it. It's in the surface data.HLSL. Okay, so we can basically just look at everything that it needs and fill them in one by one. Okay, so we've got position, normal, view direction, shadow chord, fog chord, vertex lighting, baked global illumination, green space, and a shadow mask. Some of these will be easier to get than other ones, but we have a lot of them ready to go already. So we have the world space position, have the normal vector. Okay, so view direction we can get pretty easily. See, I always use a specific function to do it. Let me see if I can find it. Okay, here it is. Okay, so yeah, we'll have this helper function here that basically gets a view direction from a position, and it just gets the camera position and normalizes the direction. I think that the lit shader might include like a view direction interpolator because it might be faster, but I don't know. I feel like the gains are not very significant. Okay, so shadows. This is another helper function. Oops. Okay, so we have this. I have this other file. Get shadow coordinate, and it basically there's two different types of shadows, either screen space or not. There's more than this actually in 2021, but for now we'll just use this one. And it needs the world space and clip space. Okay, so fog, chord, vertex lighting, baked GI. We won't worry about those yet. So let's just set them to 0 and we'll come back to them. Okay, and then screen space UV is relatively simple. I can look at the forward pass and see how they do it. Okay, so yeah, this you call this function from URP, and again, it just converts clip space to screen space. They're not that different, but there are some, I don't know, some things you have to take into account, so this function does it for us. Basically, clip space ranges from -1 to 1, and then normalized screen space ranges from 0 to 1, as if the screen was like a texture. But it needs this for basically screen space ambient occlusion. Okay, so now we need the surface data, and it has a lot of information, which we probably won't be able to support it all just yet, but eventually. Okay, so the albedo is a fancy name for the base color. I used to think that the albedo was like a technical term for the color of an object in like neutral lighting, but technically it's not. Like, because in physics it just means reflectivity. So I don't really know why it's used in shaders to mean like a base color. But anyway, that's what it is. All right. So the albedo we already have from our texture sample. So we just need the red, green, and blue component of it because we're not dealing with alpha. Okay, and then the specular we'll set to 0 for now. Same with metallic and smoothness. Okay, so this is the tangent space normal. We're not doing normal maps, so it always just points straight tangent to the surface, which you can define this way. Emission is like a glow effect, and we're not doing any of that yet. No ambient occlusion. I guess alpha we can set. Actually, technically, ambient occlusion should be 1 right now, because if it's 0, it'll look pretty dark. Yeah, no clear coat. And this is kind of to simulate like car paint. It looks pretty cool. I haven't really played with it that much, so that will be kind of interesting. But anyway, so now we finally have at least filled in temporary values for all of the structures, and we can just call this to calculate the color, and then we can return it. Ooh, so I got an error. Incorrect number of arguments to... Oh yeah, this should have been a flip 3. Okay, so there we go. And I think it's black because we didn't pass any global GI value to it. So that's why it still looks different. But technically it's using physically based rendering now. I guess there's no specular highlight because I set the smoothness to 0. Let's see. Oh yeah, because here the smoothness is 1/2. So if I set it to 0, yeah, it's similar. It still looks different because like I said, we don't have any baked lighting on this one yet, but okay. So now let's go one by one and add information as we need it. Oh, we already have the tangent, so I was gonna say we can add normal mapping, but okay, I think that's actually gonna be a more complicated thing. So let's do baked lighting first. So for that we need a light map UV, which Unity passes in text chord 1. And in 2021.2, they actually added a dynamic light map. So I'm going to just call this static for future proofing. Okay, and then we want to pass, well, we would want to pass the light map UV, but there's actually something a little fancy you can do. Let's see. Yes, you can call this, where is it? Oh, yeah, here. Declare, you can call this macro, and it will either define the light map UV or the spherical harmonics, which is basically light probes. So you don't ever really need to have both in your shader at once, because static objects use the light map and dynamic objects use spherical harmonics, so it works out well. So yeah, we'll just call this here, and then this number tells it what text core to store it into, so we'll store this in number 4. It doesn't really matter the order that you go in. Okay, so we want to pass the light map UV or the spherical harmonics into the interpolator object, and to do that we can call some more macros. So yeah, I think they're in here. Where's the vertex function? Okay, yeah, so here. Okay, and this might look a little confusing, but it's just basically calling a macro to pass the static light map UV through here. I guess I should rename that. And then also, or use the normal. Okay, so what this does is it basically just scales the light map UV. But if there's no light maps on this object, then this line does nothing, because the macro is smart enough to basically just replace this with nothing. And then similarly here, if this object doesn't use spherical harmonics or light probes, then this line won't do anything. So it shouldn't throw any errors, but let's make sure. Okay, it's good to see. And then finally we can call a sample GI, I think it's called. Let me see. Yeah, the sample GI. And this will either sample the light map or pass through the light probe data. Okay, and again, we need to use static light maps. Okay, and yeah, this is good. Okay, and the shadow mask, we already have everything we need for that, because it's basically just baked shadows. So similarly, we can just call this macro to deal with that. Okay, so when we go back, okay, good. So now we have lightened up the shadows a bit, because it's finally getting global illumination. And if I open up the lighting, where is it? Here. The lighting tab, then we can play with it a little bit. Yeah, so you can see it does respond to global illumination, so as well as environment reflections. Okay, so far so good. I guess let's handle the rest of this lighting input while we're here. So we have a fog cord and vertex lighting. This we will evaluate per vertex, and we'll just pass it as an interpolator. And usually the shaders kind of combine it, both of these values into the same variable here, because like I said, the renderer has to interpolate these values, so you want to try and have as few variables as possible. So this is called okay, well, the name just escaped my brain, but you basically just want to try to fit as many variables as you can into one, or as many values as you can into one variable if possible. Like technically we could put the light map UV in with the texture UV here, because this is only a float 2, so the light map UV could go in the other 2 channels, but we also are combining with the spherical harmonics, so it doesn't It's just easier this way. But maybe we'll stuff something else in there. Anyway, so again, to calculate that stuff, we will call these functions. And then set here. Is that what I called it? Okay, so this is a little different, but okay, and then we can just grab the values out of the interpolator structure. Okay. Invalid subscript. Oh, did I make it? Oh, it's a float 4. Oh. Did I spell it wrong somewhere? Oh. I called it fog, chord, and vertex lighting in the interpolator. Okay, there we go. Okay, so we can test this out pretty easily by turning on fog. And just we can set the start, or rather bring the end inwards. Okay, so that's interesting. So it's not working on my lit. Why is that? Okay, so this should be a fog chord. I'm gonna go ahead and change it because the longer you wait, the more lines we'll have to edit. Okay, so I set the fog chord here. I have multi-compile fog. Is there some other keyword I need? Okay, this is the first kind of annoying thing. I guess let's make sure that this is being passed correctly. Just return. So it should. Okay, so it is receiving the fog chord correctly because you can see when I change this, it is changing values, but for some reason the fog isn't getting filtered into the final color. Okay, well, let's look and see what might be causing that. Crystal fragment PBR. This will be So you can see it uses a bunch of these keywords, which we have not dealt with yet, because these were all going to be, a lot of these are defined by the material. But I do have multi-compile fog on, so the fog stuff should work. Okay, let's see. Guess when does it? Oh, I remember. For some reason, yeah, it doesn't handle fog in this fragment function, so you have to do it yourself. Yeah, I'm glad I remembered that happened before I spent hours searching. So yeah, here you can see, yeah, this fragment PBR, and then mix fog is its own function that you have to deal with, even though you input the fog chord into the input data. I don't know what that's about, but anyway, that's how it works. Okay. Oh, right, I called it lighting data. Okay, so now fog is working. I guess I should test Vertex lights, even though it's kind of a pain to do so. Okay, so first of all, I haven't even tested any lights, but yeah, so the lighting is working fine. I was gonna say, why is it not showing up there? But it's because of the texture, I think. Let's just change them both white so we can see, so it'll just be plain what's happening with the lighting. Hi, dear Hanau. Is something wrong with Twitch Mobile? Oh, you're only getting audio? That's annoying. Well, thank you for the follow. I will put this up on YouTube. It'll be live tomorrow, so maybe that'll work better for you. Okay, but so we've got this light. It's a little overexposed, but I guess that's just part of it. Okay, so let's make another one. Set it to, I don't know, blue. Okay. So now we have two, and they're both real time. So these are they're pixel lights because they're both shaded per fragment. Do I accept questions? Oh, sure. I don't mind to answer. I mean, obviously, if it's something really complicated, I might not be able to answer on stream, but otherwise, I don't mind. So what I can do is go here, and oh yeah, I should turn on the shadow stuff while I remember. Okay, so we can turn the lights to be per vertex. Okay, so now these are vertex lights. We can't really tell because the way there's a bunch of vertices on these spheres. So let me just change both of them to a cube. Okay, yeah, so we can see it's vertex lit this way because the lighting kind of goes in the square shape because it's only shading one point and then just interpolating over. So that's good to know. Okay, so I'll change it back to per pixel. change these to spheres again. I'm kind of curious because, like, technically, if you have a bunch of lights, when you make a certain amount, some of them start shading per pixel. Does it? Oh yeah, so you can see it just decided not to include this one on this specific circle because it's the farthest away, I think. But if I move it closer, then it turns off the red one. Okay, so I guess it does. Thought maybe. I think in built-in, when you have a bunch, any ones that aren't shaded per pixel fall back to being per vertex, but it doesn't look like that happens in URP. But anyway, I just wanted to test that out. Okay, we can delete those. You're looking into Unity because RPG Maker is very limiting to what you want to animate and how many frames you can use, etc. But Unity is really overwhelming. Yeah, I get that for sure. So in my opinion, is Unity somewhat more preferable for artists? There's supposed to be a question in there. Well, for me, I actually started game development with RPG Maker too, like 10 years ago or whatever. And yeah, I kind of grew tired of the limitations in RPG Maker, even though it is a really nice program. And so, yeah, I moved to Unity, but I kind of do have more of a programming background, so it was a little easier for me to get into. I still think it's probably better than like other options like Unreal. Unreal for me was kind of difficult to get into, so I think I would still recommend Unity, especially if you're interested in like 3D. But anyway, I hope that helps a little bit. Okay, so we've got this done. Now we need to start tackling all of this surface data. Okay, so I think I'll do the normal map first. Let's see here. Okay, because that one's relatively straightforward. We already have the normal and the tangent vector. Okay, so what we need to do is sample the normal map. Actually, you know what I should do first? I should do shadows, because I don't think ours will output shadows yet, which is a shame. Yeah, no shadows. Oh, it's not even set correctly. Okay, so this is the Unity one. Yeah, I've got turned around. Oh, gosh. And this is our custom lit one. And yeah, you can see there's no, we're not casting any shadows, which is an issue. You want to make a pixel game, top-down isometric, but you don't even know where to start for formatting a game like that in Unity, but you still need to kick around in there. Yeah, it's hard to get started. You're going to make a shell of a game in RPG Maker at best. You could then move over to Unity to fully see it through. You could try to do that. I don't know how easy, like you can't move over your scripts, unfortunately, because, well, I think RPG Maker uses Lua. I don't know what newer ones use, but Unity is all in C#, so if you made any custom scripts, you wouldn't be able to move them over. But that would be a good idea just for like prototyping your game. So like the game design portion of it, that would make it, it's always good to kind of start small and then maybe expand on it. But you might look up, there's something called the 2D game kit that Unity created, and it's like a fully completed 2D game that you can download and poke around with and see what Unity did. I'd recommend looking at that as a draft. Okay, so prototyping, I think that's definitely a good idea. Yeah, I like the 2D game kit. It's I found it a couple months ago, and I think it's a good starting point. All right, so for shadows, we need to add a shadow casting pass here, which we can get started by duplicating this code. And I'll call this shadow caster, and then light mode also shadow caster. Okay, good. I hope that helps you out. So most of this can stay the same, except in the shadow caster pass, basically this is going to run another version of our shader where we basically only write to the shadow map. So in this case, we don't need any of this lighting stuff or fog, so we can get rid of all that. We still do need the instancing, which we're not even dealing with just yet. And one thing I like to do is define a keyword for each pass so that our file knows what pass it's currently running, and we can modify the code slightly. So I'll call this add a forward lit pass. Keyword. Oops, that didn't work out how I wanted. And then this will be the shadow caster pass. Another way you could do it, I guess, is you could say define current pass as a, I don't know. I was gonna say you could put a string, but that'd probably be more confusing. So we'll just go with this. Okay, so in the Shadowcaster pass, the most obvious thing is that you don't need to convert or calculate anything with color. So basically how I'm going to handle that is we'll just say we output black, and then if shadow caster pass, or wait, if the forward lit pass, then we'll, or if forward lit pass is defined, then we'll do all this. And we could just set color, then indef, and then we'll just return that color. So none of this code will run inside the Shadowcaster pass. So it'll effectively look like that. You kind of started like, oh, it'd be cool if you did sprites and then pretend it's like a game. And then you remembered RPG Maker from a sale. I did love RPG Maker. It's really nice for like, you know, for what it's made for, RPGs. Oh, okay, cool. I'm glad that you found me that way. Yeah, it's nice to meet you too, dear Hanao. Thanks for coming by. I don't know. Yeah, right now I'm working on shaders, which is pretty much like a program that you run to color models on the screen. So I don't know. I guess you can run them on sprites, but not sure how useful it will be for you specifically at the moment. Okay, so yeah, I think it's saying there's an error. Oh, I forgot the semicolon. That's okay, and then undefined PBR color. Okay, so I just need to change that because I renamed that variable. Okay, so now we still work, but you can see it looks really bad. And this is because the way shadows work is they output basically, it kind of renders like another texture. And if you write the shadow on exactly the surface of the mesh, then you get this kind of pattern, which is called, I've always thought the name was kind of weird, but technically it's called shadow acne. So we want to try to improve that. There's a couple techniques. Okay. I'm also going to grab this from my foliage shader. Thanks for the info, though. You know what's going on. Oh, no problem, dear Hanao. Yeah, feel free to contact me even if I'm off the stream. I don't mind to give any some little pointers? Okay, so we want this stuff because it helps us calculate a slightly different clip space position when we're in the shadow caster. And what we do basically is we slightly adjust the clip space position based on our normal vector or the depth from the camera. Yeah, I don't need. Okay. I'm just going to delete these comments because they're probably going to be out of date. Yeah, we don't really need to deal with double-sided meshes, for example. Okay, so we just apply the shadow bias based on the position and normal, and then yeah, we also have the light direction and the shadow caster pass. Okay, and so this is kind of confusing, but sometimes Unity has to reverse the Z on the clip space, and you do this basically so that you don't like overshoot the bounds. Am I on Twitter? Oh yeah. Yeah, Ned makes games basically everywhere. But I put a bunch of links in my about tab. So what we'll do is when we calculate the clip space position, if we're in the shadow caster pass, we'll handle it slightly differently. So yeah, we'll just call this function instead of using the value that was calculated previously. Which again, the compiler is smart enough to throw out that calculation, so it's not like we're calculating it again. We're just not using that field from the structure. Okay. All right, so yeah, still a problem. Oh yeah, this should be if defined. I always forget to do that. Still. Oh, I forgot the S. Okay, there we go. So yeah, no more shadow blemishes, and we're finally outputting a shadow caster. I don't know, maybe it's just me, but it seems like they're casting at different directions. I don't know why that would be. Okay, I'm not doing this right. I want to have it point straight down. Okay, I guess it was just a perspective. Yeah, because I think it is fine. Yeah. Oh yeah, when you turn it isometric, yeah, it was just a perspective. Okay. Oh yeah, so neither of these. Oh yeah, these point lights actually, yeah, they won't cast a shadow because I'm working on 2020.3 right now, which doesn't have point light shadows. But we can make a spotlight just to test it. Okay, glad to have you back. I'm going to set that to 0. Point it on our custom lighting and turn the shadows to soft shadows. And then we'll increase the intensity. Okay, yeah, so we're getting also spotlight shadows, so good to see. All right, so we've got shadows. There's a couple other things I'd like to add while we're here. Let's see. So some other passes are the depth only pass for making a depth texture. is for things like well, you use depth texture a lot in custom shaders like outlines. I'm not sure what Unity uses it. I can't think of it off the top of my head. But anyway, we can support that really easily. And then also there's a depth normals pass, which creates like basically it outputs the normal vector of everything on the screen into a texture. And this is used for like ambient occlusion and things like that. And also outlines. Okay, so depth only is really easy to support. All we have to do, well, basically we don't have to do anything because this will just run as normal. And then in the fragment function, it will return 0. But depth, the depth normals pass, we do have to do a little bit different because the color we output is actually the normal vector, and we have to encode it in a special way that basically gives us the best precision possible. And we can find it. Let's see here. Yeah, depth normals pass. So we can use this function. So yeah, it's it's packed normal oct rect encode. So you don't have to worry about specifically how this works, but basically it just transforms the normal vector into a specific format that the normal texture accepts. So we could just set the color to that, and we're good to go. Okay, so we can make sure it's working by adding a screen space ambient occlusion pass, and then we can look in the frame debugger. Okay, and then if we can look for the depth normals pass. Okay, and so you can see basically the colors aren't really what you'd expect, but they look, actually they look kind of different. I was thinking these spheres would be the same. I don't know if it could just be the perspective because it transforms it into view space. If I change the camera to orthographic, okay, so then they're basically the same. So I think it's okay. So I've been in game development for 10 years now. Yeah, I've been programming since I was like a teenager. So, and yeah, I'm not a teenager anymore, but you're gonna try to move over to your laptop so you can maybe at least see what's going on. Oh, right, I forgot that you're audio only. But yeah, hopefully that'll work for you. Okay, so yeah, so this is the depth normals pass, and let's change to the, if I just change this to use depth, then it will just use a depth only pass, and this also is working. So I like to use the screen space ambient occlusion to kind of test if everything is good. I guess now we can actually test the screen space ambient occlusion to see if it works correctly. To do that, we can basically just move this. I guess I'll disable these extra lights. Let's move that over. And if I move this close by, it should be, yeah, you can see there's a slight shadow, and it will probably disappear if I turn it off. Yeah, so that's the ambient occlusion working. Okay. Oops. Okay, cool, you can see now. Yeah, shaders are really fun to work with. I enjoy it quite a bit. There's nothing like seeing all your code actually draw something on the screen. It's pretty fun. But okay, so we've got well, technically there's one more pass. There's something called the meta pass, which is used for baked lighting. But I usually handle that in a separate file because it's quite different. So yeah, let's not do that. I'll leave that for later, but I don't want to forget about it, so I'm gonna add a little thing here. Okay, so now we've got... Okay, I guess now we'll do the normal mapping because we can finally move to that. So we'll add another property here for the normal map. And we'll have the normal strength property, which basically is just how much the normal map affects the normal vector away from like straight tangent, or not tangent, but straight up in tangent space. So we'll start this at 1, and we can also set this to be a range between 0 and 1. Hey, jar coding. Thank you for all my videos and streams. It's really cool. Share your knowledge with us. Always really inspiring to watch. Oh, well, thank you. I'm glad that you say that because it's one of my main goals with these streams for sure. Is it possible to see the stream later because it's really late here? Oh, yes. I will upload every stream to my second YouTube channel, which I think is just Ned Makes Games 2. I'm pretty sure that's the URL. But yeah, it goes live tomorrow at 5. Or I guess it would be 6 US Eastern time because I have to wait until 24 hours after this stream because of Twitch's TOS. But let me see. Ned Makes Games 2. Yeah. Yep, I have all my streams up here. Thanks, dear Hanau. All right. But anyway, yeah, so feel free to watch in there. Yeah, the second YouTube channel is mostly just streams. Because YouTube, the analytics on YouTube are kind of weird if you post something that's way different than your normal stuff. So I wanted to just be safe. All right. So normal maps. We got the normal map and the strength. So now we've got to create the properties here so that we can use them in HLSL. Oh, right. And I want to make it so the normal map doesn't have its own scale and offset because it should just match the color map. And you can do that with this little attribute. I think that's the right one anyway. Okay, no. Is it no scale or offset? Nope. Okay. Let's see. All right, well, I guess it's not super important, but I'm kind of curious what the thing is now. So Unity, shader, no scale, offset. Okay, so it's just no scale offset. It doesn't need an and or an or. Okay, that's fine. Okay, so now, oh yeah, good. So now it took away that tiling. Okay, so in order to get tangent space or normal map to work, we have to calculate the tangent space transformation. But I guess first we'll sample the normal texture. Let's see here. I think I'll yeah, we have to do some fancy stuff because because remember, the normal is encoded in this specific way. So we need to decode it and then transform it to world space. So I forget exactly what the math for that is, but thankfully I have it here already. All right, so thanks, Jar, for subscribing. I really appreciate that. It's really nice of you. See me tomorrow on YouTube. Oh, feel free to comment. I do read all my comments, so even if you can't watch there live, or watch anything live, I'd still like to see what you thought of the stream. Okay, good night from Europe. I hope you have a good sleep. Okay, so first we need to create a tangent to world space matrix. And what this does is let us transform a tangent vector or a normal vector that's in tangent space to world space. And we can use this specific function. I think this was in for shader lib space transforms, which I guess we can look at. Okay, yeah, so this isn't in the URP, it's in the shader pipeline core library. Yeah, space transforms. Get rid of some of these. I'm getting too many tabs open. Okay, so this has a bunch of different ways to transform from different spaces, but yeah, so this is the one we want. Create tangent to world matrix. And it's actually, I mean, the math behind it is a little complicated, but the actual creation of the matrix is pretty simple. You just put the normal tangent and bitangent into a matrix like that. But anyway, again, it's not super important to know the math, but okay, we're not gonna, don't have to worry about flipping the normal. Okay, so tangent space and then normal. Okay, so does this, I guess this transforms to world space too. Because you can see here we move the vector into view space, which is camera relative. But we can test that. Oh yeah, I never added the normal strength argument there. Okay, so I think this is fine. All right, so now here, every time I use this input.normal, I need to use the real normal vector. So there as well. Okay, and then for some reason they asked for the tangent space vector here. I don't know if it's ever actually used, but we'll just fill it. I don't really know why you'd need that for lighting calculations, but okay. So we've got an error, undeclared normal world space. Oh, yeah, I just need to tell tell it that that's a float 3. Okay, so something is wrong. Oh, it's because right now the normal strength is 1, but the texture is empty, so the normal is always getting perturbed. So yeah, we can just set that to 0 and it should look regular. So if we put on this test normal map, then yeah, we can add it and it gets these nice waves because yeah, the normal map is basically perturbing the normal vector on the surface. So let's see if it looks the same as the Unity version. I'd say it does. Just trying to look think it looks just as good. So yeah, they have this also to change the strength. So if we set it to 0, again, that doesn't do anything. Okay, so I think, yeah, that function just handles everything. Yeah, I'm changing the camera because I'm trying to see if it changes with the camera position. Because again, I'm still just a little worried that it doesn't transform out of view space, but it looks like it does, so I think we're good. Okay, so now I guess the next thing to handle is like metallicity and smoothness. I'm not sure. I don't remember what the specular thing is. Let me look. Oh, it's probably for the specular workflow. I always use the metallic workflow, but let's see what it puts in there. Oh, okay. I just remembered something else that I should do, but what's it? Oh, initialize. Let's see. Where does it do that? So this is always fun. When you see a function in the shader library, you kind of have to go searching for it because you can't your Visual Studio won't be able to find it for you. So you can either press Control F to try to find it, but that's usually kind of annoying to do. So once you've worked with it enough, you can kind of think about where it might be. So I think this is in the shader library. Maybe, so we know the surface input. Okay, so it just has like stuff for alpha clipping, which we do need to get to. Okay, surface data does not either, unfortunately. But input. This has various matrices. Maybe it's. Let's see, maybe it's not in the input or in the shader library. Maybe it's here. Okay, yeah, so it's in the simple lit input on the shaders, not the shader library. So this has like the actual shader stuff. The other one's like common code. Okay, so it's saying it doesn't use the metallicity. I don't think that's correct. What does it mean there's no occlusion? Oh, this is a simple lit. Okay, I was gonna say. Then where is this? I guess the lit input has it. Okay. So. Okay, so albedo alpha, space map, the metallic and specular gloss. Okay, so yeah, if there's specular setup, then it sets metallicity to 1. Okay, otherwise the metallicity is okay. The smoothness is in the alpha. Okay, so I see. So I guess that's if you wanted to have a specific specular color. I guess we'll just do the same thing. I guess because we are recreating it after all. Usually I like just to cut down on the number of textures because now you have to have a separate texture for ambient occlusion, but because since I always use the metallic workflow, I would put metallic in red, smoothness in green, ambient occlusion in blue, but I guess it doesn't really matter so much. Okay, so we'll have let's see here. Some more texture maps. So spec gloss map. I want to call it. And we can maybe make this better with our custom importer, which we're going to have to do at some point. Okay, and then I guess I'll have some other stuff here. So, I guess, yeah, while we're here, I want to have like a color tint. So, I guess we'll do the same thing with this. So we'll have metallicity. And then we'll do smoothness. Only need 2. And then we'll need a specular hint. Okay, and then we'll have, I guess ambient occlusion. How does it, oh, I think yeah, for ambient occlusion, I think it's kind of complicated because where'd the file go? Oh, it's right here. Because yeah, this sample occlusion, they sometimes calculate it in different ways. Let me see if I can find it. Yeah, if there's an occlusion map, then it might put it in the green. Oh, I don't know why. Oh, okay, we'll have to look into that. Oh, no problem, dear. Now, to go through your servers to clean them up so you could join. That's okay. Okay, and then of course we have clear coat and emission. I mean, I guess we don't have to. Well, I kind of want to recreate it, so I need to look and see specifically why it puts the occlusion in the green channel. I think it's because the green channel usually has the highest precision. But I thought, okay, let's see. Guess like, oh, okay, so you can change the source of the smoothness. Okay. Oh, I see. I thought that there's, I was getting confused because I thought you could change the smoothness source to be, or I thought you could change the occlusion source, but it seems like the occlusion has to go on its own texture. Okay, yeah, so again, I just want to copy it. And so it has a height map too. But I know it doesn't have tessellation, so I don't know what the height map does. Does it? Oh, I bet it's for like parallax, but I don't know where that's handled. Okay. Yes, this is a bit more complicated. I wonder. I mean, we could probably just use these functions instead of. Oh, well, no, because then we'd have to like name everything the same. So that would be a little bit confusing because I was going to say we could just include this file and then reuse everything, but I guess the other thing is we are like making our own file, so I don't have to, our own shader that recreates the way it looks. Maybe it doesn't have to like, you don't have to have it behave the same way. Otherwise, why not just use the lit shader? Okay. Anyway, that's all something to think about. Oh yeah, my cat's been here most of the stream. She usually doesn't hang out here during stream time, so you're all in for a lucky treat today. Okay, so this is like a minimum for the occlusion. I guess just do that. Make that more human readable. Okay, and then the last map that I'm going to deal with right now, because I need to look at the height map, I guess. I didn't know that they had, I guess I missed it, but I didn't know they had parallax, but apparently they do. Oh, this is Toasty or Jade. She has two names depending on how we're feeling on that day. Plus, who knows how many nicknames, but okay. Oh yeah, mission. That's what I was looking for. Okay, so let's add all of this to our shader. So we've got normal map, the metallic specular gloss. Occlusion. I guess we could put occlusion and yeah, technically the occlusion can go on the emission, can't it? Because the emission has 3 colors, and then the occlusion would be on the alpha. And if you didn't want any emission, then you could just set the emission tint to black. Maybe I'll do that. Let's see. Is there a reason? Usually Unity won't do something if there's no reason to. Sample emission. Okay, so let's see what does that. Oh yeah, and there's detail maps too. Okay. I forgot how many features were in the lit shader. I was trying to find this function, but I don't see it here, which is, oh, yeah, there it is. Oh wait, no, that's the occlusion. I want the emission, sample emission. Okay, I don't see it. So it's not in this file. Okay, so you could look here. Maybe it's in this common material, hopefully. No. At least I don't think so. Oops. That's a shame. Where is it? So, is it in parallax mapping? Okay, I'm pretty sure it's not surface input. That just had the structure. Oh, I was looking in. Okay, that was the core. Okay. We want. Oh, surface input. Okay, it's different. So here's emission. So all it does is just sample the emission. Okay, and then if it's turned off, then it doesn't sample it. So. Okay, so yeah, we could combine them. I don't know why. I don't know why they put occlusion in its own map separate from emission. Maybe it's just because that's easier for the artists to work with. But then they combine all the metallic and specular stuff together, so I don't know. Because technically if you had both, you could make this more efficient by combining them into one texture. So I kind of want to do it, but I guess let's see. Unity. Why is occlusion its own texture? Occlusion maps grayscale image with white indicating areas that should receive full indirect lighting. Sometimes it's as simple as a grayscale height map. Other times, generating correct occlusion is slightly more complex. So occlusion map identifies areas on the character's sleeve that are exposed or hidden from ambient lighting. Okay, so yeah, this doesn't explain why it works how it does. It just says it. The main problem from enforcing a texture input for the height map is that it inherently precludes its use in complex shaders that are made up of multiple passes. Okay, so yeah, this is a little bit more complicated than I care about right now. Okay, you know what? Technically we could save some, but I guess that's kind of over optimizing. Although I just don't know why. In that case, they combine everything onto this huge metallic texture, but anyway, so this is fine. Alright, so I wanted to change this to emission tint. No, I guess let's start as white. Okay, so anyway. Okay, so now we have metallicity, if I can spell it. Smoothness. occlusion minimum. And then, oh yeah, then I had all the different tints. So for color tint, float for specular tint, float for emission tint. So let's make sure I didn't forget something. Okay, I think that's right. So now that we have all that stuff, we can add it in pretty easily. So the albedo would be, just need to add the color tint to it. And same with the alpha. Okay. Okay, so the specular color, I'm just gonna add the specular tint only because right now I'm gonna just work in metallic mode. Well, I wonder if it matters. Okay, I guess we gotta sample it anyway. So this will be metallic, specular, smoothness sample. Let's do that. Okay, and then we've got occlusion sample. Oh, I forgot the underscore. And then the emission sample, which again is like kind of glowing light. Okay. So we've got all that. Well, okay. I don't know if this will really matter. I'm gonna go ahead. So specular is the RGB of this if it's in specular workflow mode. Otherwise, the metallic is red. And then the smoothness is always, I guess it's not always, because sometimes it's, smoothness is in a different texture, but. Okay, and then emission sample. And then occlusion sample. It's on the green for whatever reason. And I'm gonna lerp from the ambient occlusion minimum. Okay, yeah, so we don't handle clear coat yet, but I'm gonna save that for probably last. Okay, I guess I spelled that wrong. Okay, so it's showing up white right now, because okay, I just wanted to see what it was complaining because I was ignoring the alpha component. So it's just making sure that I didn't mess something up by accident. But yeah, so this is white because the emission is always set to white. So if I just set this to black, it'll go back to normal. Okay, we can see we're getting some smoothness. So that is a little funny because it's this, I guess it's saying that the metallicity is not affecting anything. Okay, because I misspelled it. Okay, so yeah, now it's definitely metallic. Basically, that just kind of says how reflective the surface is. And of course, we have the normal map. And okay, so the occlusion minimum should actually be a range as well. Okay, well, it's not doing anything because nothing is occluded right now anyway, because the occlusion map is completely white. But if I changed it something like that, you can see when because now it's having occlusion on certain sections of the texture. But when I set the occlusion minimum to 1, it kind of just overwrites some of them. Okay, so let's set this all to white just to make it obvious. And then I can... So now it has different smoothness and metallicities. Set this neutral gray, how about? Okay. I guess we could set emission. Okay. So the emission doesn't actually affect anything. Well, 1, because it's not static, and 2, because we haven't set up a meta pass, but it does look a little different, but I think it's because we set metallicity and smoothness fairly high. Okay, so now they look about the same. So if I set... Okay, that's good. Okay, so this actually changes it because I think it's an HDR color. So if I want to... Oh, no, so this does look different now. What's going on? So I got the... Oh. No, that doesn't matter. Oh, I had metallicity off. Okay. So this is 0. So let's speed this all the way up. Okay, yeah, so they look the same. Alright, so far so good. Okay, so guess we just got this stuff going on, but for a lot of it, we kind of need to be able to set keywords on the material. So I guess I just need to like go through each of these options and make sure that we can actually handle them. So for like this is the specular work throw is like a completely different way to work with the material. Instead of like setting a metallic color, you set like a specular or color for the specular highlights on the texture. That looks cool, actually. I wonder, like, if I set a specular tint, does it... I don't think it affects anything if I don't have... if I'm not set to specular work mode. Okay, so there's a lot of little features here. Yeah, it's actually relatively complicated, so I kind of wonder like how much do I actually need to recreate for this tutorial? But I guess we should just do what I can, and then yeah, we'll see what makes it into the complete tutorial. Okay, so let's see if we can find Unity URP custom shader inspector. I'm surprised there's something about it. It told me this was for URP, but then it takes me to this built-in. Implementation for custom material inspectors differs between URP and HDRP. For compatibility purposes, every custom material inspector in HDRP must inherit from HD shader GUI, which does not exist in URP. Okay, so I guess it's just the same. URP just uses the same as the built-in inspector. Okay, and then you add this custom editor field to your shader lab file with the name of it. Uses could demonstrate syntax for specifying a default custom editor for a shader using a custom editor block, and then specifying 2 additional custom editors for specific render pipeline assets. Okay, so if you had more than one render pipeline in your project, you can set different ones for them. I guess that's useful. I don't really know. Okay, let's get started by copying this and add a new folder for the editor. Oh yeah, I'm gonna have to pop back into Unity and create my lit custom inspector. It's gonna have to reload because it's creating a new editor project. Okay, there we go. So my lit custom inspector, and then in the my lit shader we'll add that custom, what was it? This. Okay, I wasn't sure what curly brace to put it under. Okay. So nothing should change really because they haven't added anything, but if I click on the material, okay. Cannot create custom UI. The shader has the following custom editor. lit custom inspector. Does the custom editor specified include its namespace? And does the class either derive from shader GUI or material editor? Okay, so it's saying it can't find it, I suppose. Well, it has no namespace, so place the custom editor block inside the shader block. You can also assign different custom editors for render pipelines based on crypto render pipeline by placing blah. If your code contains a custom editor and a custom editor for render pipeline block, the render pipeline overrides the custom shader. Okay. Alright, so this is also out of date because the other page said that the HDRP should not use this, but I'm sorry if you, I don't know if you can hear it, but somebody's playing super loud music outside my window. Let's see. Well, I guess I can look. The lit shader should have this as well. Okay, so it uses the namespaces, but I don't have a namespace. So maybe I misspelled it. Okay, well maybe we can find Unity's custom inspector, and there's something else going on. So it uses base shader GUI, which different. Could not find material properties surface. Okay, so where is this file? This is in the universal render pipeline. Oh, sorry about that. Okay, so this kind of adds a bunch of stuff that we might not want to use because it's kind of, yeah, it's using like a bunch of math, or not math, like logic for this URP shaders that we kind of want to just re-implement ourselves. Okay, but what does this, okay, this one just inherits from the shader GUI, so I guess I was correct. All right. Oh, I guess it's, it's working now. What did I change? Okay, well, let's see. So I want to just print a label. don't remember. It's been a while since I've worked with Unity editor stuff. Some fancy stuff in here. Nothing even uses this, so that's good to have. Some of this stuff is really fancy, like UI stuff that I don't know. Probably won't replicate, but I just want to render. Okay, so here's like a toggle. I guess let's just do this. I just want to see if it actually shows something different. Okay, so toggle. We'll just return false. What's the... Oh, it doesn't even have any text. Oh, yeah, it was right here. Okay, so text first, and then the value. I see. They were doing like, localization. Okay. So now I should just have this test toggle that'll appear on the top of the inspector. Okay, and it does. So it doesn't actually do anything, but since it's there, we know that our inspector is up and running. Okay. So the reason we want to do this is because we want to be able to set a bunch of keywords on the material depending on what properties are selected. So I'm just trying to figure out what to do. Okay, so here's a way to set a keyword, so that's nice to know. But has property, I guess. Does this return false if there's no... Checks the material shader has a property of a given name. I was gonna say, how does it know if there's like a texture set in there? That's what I'm trying to figure out. Oh, I see. So it has this emission enabled value that they use. Okay. So they store like flags actually in the material, which I guess is fine. It doesn't affect the shader itself. Okay. So what do we want to do first? I guess let's just start from the top of the Unity lit and see if we can replicate things. So first it has this workflow. So we'll want to switch between metallic and specular. Yeah, I don't think I'll worry too much about making like the editor itself super pretty, because I mean, there's a lot that went into this. Maybe, I don't know. It's not really important for the tutorial, I don't think, because the tutorial is not really on about creating a editor, but we do need to have it so we can change, like, again, the workflow and stuff. Okay, so let's do, here is, editor state only variables. So hide in inspector. Well, I guess we don't really have to hide it because now that I think about it, we don't really need a custom inspector because we can just use a toggle keyword. So I don't know. Yeah. Okay. So I was kind of making a mountain out of a molehill there, but that's okay. Okay, we can just do toggle. Okay, so I guess what's, well, metallic is default. So be specular. What's, yeah, it has a specific name. So okay, so not showing up. I was like, where was that? Is it here? Oh no, it was wherever this initialized standard lit surface data was. I forget. Lit. Oh yeah, it's here. I think lit input. So okay, so we have specular setup, but I did not see it here. So it doesn't really have a shader feature. Oh, it's right here. I don't know why. Okay, so yeah, when you have the shader local, what it means is basically Unity will compile a version with this on and with this off. I wonder. Yeah, I think this is used somewhere else too in the lighting. So I don't know if I have to make sure it matches, is what I'm curious about. Okay. Oh, I lost complete track of time. Let's go ahead and see if I can finish this one thing. Okay, so let's see if we can find the specular setup. Okay. Oh yeah, so this is in the lighting as well, and we can see if specular setup is on, then it uses the specular for all this stuff. Otherwise, it just uses the metallicity. Okay, so I do need to make sure I use this exact keyword. Let's go ahead and do that. Okay, so this toggle should let us just toggle it on and off. Let's do specular setup toggle. Use a specular workflow. Oh yeah, so I don't really need this right now. I have a feeling, actually, I'm pretty sure we're going to have to use the editor for some things because I think we'll have to use it to change like this render type, for instance, but we don't really have to use it for this. So if I turn it on, then I can put this on, and then if we turn metallicity and smoothness, oh, metallicity isn't used in this one, but, and then if I go to the Unity lit, we should be able to get the same thing by switching to specular mode and turning smoothness up. Okay. Cool. And then if I turn it off, then this is goes back to being metallic and smoothness map. Okay, that was pretty painless. All right, so we still have quite a bit left to do. So we finished this. So we got the surface types, render faces, all this stuff. Let's just say finish adding options from the lit inspector, and then we'll just go from there about what else. But yeah, I guess I better call the stream now. It's getting relatively late for me and I need to finish some other stuff today, but thanks everybody for coming by. I really appreciate all the chatters we had today. It was nice. And thanks again, Jar Coding, for your subscription. It was it really does mean a lot to me. And for everybody else, like for Dear Hanau and for following and stuff. But I'll put some chats, or I'll put some links in chat if you enjoyed the stream and you'd like to connect with me on any other social media. And I'll be live again Friday at the same time, about 2:15 US Eastern time. And I guess we'll probably continue with this. Maybe try to implement the rest of it. Yeah, we are going to get into some more fun stuff, so should be a good time. But yeah, again, thanks everybody for watching, and I'll see you Friday. Have a great night. Bye-bye.